Chillo, peeps! This video is your Chapter 7 study guide. Well, part 1 of it anyway. I want to remind you that the 7.5 worksheet that you're doing as well also constitutes as a part of your study guide to prepare you for your test, because none of those types of questions are on this study guide, but you do need to know how to do those for your test as well. Okay, here we go, page 1. A few things that I want you to remember, like number 1 through 4. Well, actually, for any question that might pop up on your test, you need to have solid knowledge of the unit circle. So today in class, I kind of went over some tips for you to remember how you can set up the unit circle rather quickly without feeling overwhelmed, like you have to memorize everything, and knowing that if you know the first quadrant, you should be able to figure all of the other quadrants pretty easily. So tomorrow your test will consist of the unit circle and 4 proofs, and Thursday's test will consist of a regular format of multiple choice and free response questions. Once you know your unit circle, it's going to make this question easy. Number 1, 2, 3, and 4 rather easy. Without kind of looking at the unit circle as is, we will use what we know about reference angles to figure out these. So if you recall, in order to find reference angles, something in the first quadrant, its reference angle is itself, just alpha. In the second quadrant, we have 180 minus alpha. Third quadrant, alpha minus 180. Fourth quadrant, 360 minus alpha. So we can use this to help us for 1 through 4. It says use what you know about the unit circle to find exact values for the following. No decimal approximations. So you can't just plug this in your calculator and approximate it. So the sine of 240, thing to realize is that 240 is in the third quadrant. So if I want to find its reference angle, then I'm going to do 240 minus 180, which is 60. Okay, so I know the reference angle is 60 degrees. Well, if at 60 degrees, if you recall that the coordinate points for that are 1/2 common the square root of 3 over 2, then that implies that because 240 is in the third quadrant, its coordinate points are going to be the same two numbers, except they're both going to be negative. So negative 1/2, negative square root of 3 over 2. And sine value is the y coordinate, right? Sine is the y coordinate, or y over r. And therefore the y coordinates at this point, or at this angle, is negative square root of 3 over 2. So the sine of 240 is negative square root of 3 over 2. Number 2, what is the cosine of negative 270 degrees? Well, the thing to realize here, and again, if I use this reference angle chart up here at the top, the negative really always just has to, or really only has to deal about direction. So positive direction is if I rotate counterclockwise. But if I go a negative 270 degrees, that means I'm going to start at 0 and I'm going to go backwards. So negative 270 degrees is going to land me in the same spot as if I went a positive 90 degrees. So then the cosine at 90 degrees, well, the coordinates at 90 degrees are 0, 1. If I ask you for the cosine, I want to know what is the x coordinate at this point. Therefore, I can say that the cosine of negative 270 degrees, x coordinates, is 0. Number 3, the tangent of 135 degrees. Tangent is found by dividing your y coordinates over the x coordinate. It's like slope, right? So the thing to remember about 135, again, let's assume that you don't have your full unit circle here. Then if we know that it's in the second quadrant, then we could take 180 minus 135. And we're going to end up with 45 degrees. So that means, oh, my dogs are fighting. That's great. So that means our 45-degree angle is our reference angle. Well, we know at 45 degrees, our coordinates are square root of 2 over 2, comma square root of 2 over 2. The only difference between 45 and 135 is that your 135 degree angle is in the second quadrant. So it's going to have a negative x value, negative square root of 2 over 2, positive square root of 2 over 2. If I ask you for the tangent tangent is found by y over x. So if I put square root of 2 over 2 over negative square root of 2 over 2, that's essentially the number over itself, but one of them is negative. Therefore, the tangent of 135 degrees is going to be -1. Number 4, the tangent of 30. Again, tangent, y over x. At 30 degrees, my coordinate points are a little bit more complicated. At 30 degrees, I have square root of 3 over 2 and then 1/2. So if I divide y over x, I'm going to have 1/2 divided by square root of 3 over 2. I hope those of you that are watching this video are getting a kick out of my dogs just, being typical of what they're usually like on a daily basis during class anyway. Dividing stacked fractions like this is the same thing as multiplying by a reciprocal. So that'll be 1/2 times the reciprocal of square root of 3 over 2 is going to be 2 over the square root of 3. And then if you multiply straight across, these 2's will cancel. 2 over 2 is 1, leaving us with 1 over the square root of 3. And we can't have radicals in the denominator. So if I rationalize this by the square root of 3 over the square root of 3, multiply straight across again, I get my final answer for tangent, which will be the square root of 3 over 3. So that's basically using your knowledge of the unit circle to find these. For 5 through 8, these are all going to be similar to each other, and I'm asking you to assume that theta is between 0 and 90 degrees. Actually, this should probably say less than or equal to 0 and less than or equal to 90. Main thing is that it is in the first quadrant, okay, quadrant 1. So number 5 says, if the cosine of theta is equal to 1/4, find the tangent of theta. Now, I've noticed some people using triangles to set these up, using your right triangles and, drawing and labeling them based on what you know about the ratios. I am fine by that as long as you do it correctly. Since this chapter, though, is dealing with the identities, I'm going to use my identities to help solve these, okay? And if I ask you on your test to solve using an identity, you have to show me that you know how to do those. So basically, I know that if I'm going to try to find tangent of something, I know tangent is sine over cosine, and I have the cosine, so the first thing I want to go find is sine, okay? So if I try to find sine, I can use one of my Pythagorean identities, which says that sine squared theta plus cosine squared theta is equal to 1. And then I know that cosine of theta is 1/4. So then I've got sine squared theta plus, instead of cosine, I'm going to put 1/4 squared is equal to 1. So then I get sine squared plus 1/4 squared is 1/16 equals 1. And then if I subtract 1/16 from both sides, I get sine squared theta is equal to 15/16. And then I get that the sine of theta is equal to, when you take the square root, you have to remember your plus or minus symbol, square root of 15 over 16. Okay, so furthermore, I can still continue going on with this. That means the sine of theta, because I am in quadrant 1, I know that I'm going to use the positive version. And then the square root of 15 over 16 could literally be broken up to be the square root of 15 over the square root of 16, which can further be simplified to say that sine theta is the square root of 15 over 4. Now, that's not the answer. The question is, what is tangent of theta? So if we know that tangent of theta is sine theta over cosine theta, and I now have sine and they gave me cosine, then that means that tangent of theta is equal to sine is square root of 15 over 4 over the cosine, which is 1/4. And then we can, kind of like we did earlier, if you have stacked fractions like this, that means the tangent of theta is equal to, I can leave, it's the same thing, some of you have learned it as keep, change, flip. Square root of 15 over 4, we're going to keep the same. We're going to change our operation from division to multiplication. We're going to flip our second fraction, 1/4, to be 4 over 1. When we do that, and we multiply straight across, these 4's cancel out, leaving us with our final answer of the tangent of theta is the square root of 15. Number 6, if the sine of theta equals 2/3, find the cosine. Oh, side note, I want to go back over here for a second for tangent, because what some people are doing, oh no, it's not on that one. It'll be number 7 that I say that on. Okay, sorry, number 6. I need the cosine given the sine. So we could use one of the tactics we used for number 5, which you could use a triangle, but I'm going to use identity. So if I use a Pythagorean identity that says sine squared theta plus cosine squared theta is equal to 1. I know sine theta is 2/3 plus, I don't know cosine squared theta, so I'm going to leave that alone, equals 1. Oh, sorry, this should be 2/3 squared. Don't forget to square it. So 2/3 squared is 4/9 plus cosine squared theta is equal to 1. If I subtract 4/9 from both sides, then I get cosine squared theta equals 5/9. Okay, to get cosine alone and not squared anymore, I'm going to take the square root of both sides. I'm going to remember my plus or minus sign, and that's going to be the square root of 5/9. So again, we have to remember that we are in quadrant 1. In quadrant 1, everything is positive, so I'm going to choose the positive version. And I can break up the square root of 5/9 to be the square root of 5 over the square root of 9. And further simplify it to be the square root of 5 over 3. And they asked me for cosine, and I am there. There's nothing else you have to plug that into. So cosine of theta is square root of 5 over 3. Number 7, here's the mistake that many of you made on your test. You're recalling one of the correct things, which is that tangent of theta equals sine theta over cosine theta. So what many people are saying is, oh, well, if that is 7 over 2, because tangent 7 over 2, then that must mean sine theta equals 7, and I'm done. And unfortunately, that is extremely terribly false, because what you're essentially claiming is if I give you two fractions, so if I tell you 1/2 is equal to 5/10, what you're claiming by doing this is saying that 1 is equal to 5, which you and I both know is very, very far from the truth. So you cannot make this assumption here. That's not how proportions work. The two numerators are not equal to each other. So this one's going to take a little bit of work. Again, there are multiple ways to solve this one. I'm going to use a couple of different trig identities, and one of them is going to be one of my Pythagorean identities. So I notice one of my identities has cotangent and cosecant, which is both the reciprocals of tangent and sine. So if the tangent of theta is 7/2, that means the cotangent of theta is 2 over 7 because it's the reciprocal. So if I have that, and then if I use that identity I just told you about, 1 plus cotangent squared theta equals cosecant squared theta, then that means I can plug in cotangent and solve for cosecant. So then I have 1 plus cotangent will be 2/7 squared is equal to cosecant squared theta. So that'll be 1 plus 2/7 squared will be 4/49 equals cosecant squared theta. If I change this 1 to be 49 over 49, and again, you'll have your calculator, so you'll be able to add those fractions, but this saves time sometimes. 49 plus 4 is 53 over 49 equals cosecant squared theta. So I need to solve for cosecant by taking the square root of both sides. So that means cosecant of theta will be plus or minus the square root of 53 over 49. Again, I'm still in quadrant 1. That applies to questions 5, 6, 7, and 8. So that means cosecant will be the positive square root of 53 over square root of 49, which will be the square root of 53, 53, that is right, over the square root of 49 is 7. Okay, but I don't need cosecant, I need sine. So if you remember that sine is the reciprocal of cosecant, then that means that the sine of theta, I'm going to take the reciprocal, will be 7 over the square root of 53. But I cannot have a radical in the denominator, so I'm going to go ahead and rationalize it by multiplying by the square root of 53 over itself. And then if I multiply straight across, I get sine theta is equal to 7 square roots of 53 all over 53. Number 8, if the tangent of theta equals 2, find cotangent of theta. This one may be as easy as you think. If you remember that cotangent is the same thing as 1 over tangent of theta, then that means that cotangent of theta is literally 1 over 2, since the tangent is 2. So cotangent is 1/2. For number 9, 10, and 11, these questions are similar. I'm asking you to write the equations as a value, so telling me I want to have a number of one trigonometric function. And that's the key, right? Because in some of these, I'm giving you more than one. So the key is to use your identities to consolidate them to one trig function. And you're going to use some of your proof strategies here. So you want to basically change some of these functions or some of these some of your trig functions to others and try to consolidate. So for number 9, my recommendation is leave sine of x alone and change cotangent. By using your quotient identity, the cotangent is the same thing as cosine of x over sine x, and that is equal to 1. Now, this is not a proof, so you are allowed to algebra, I'll say. And not that I need to cross the equal sign, but if you realize that sine of x is over 1 and you multiply these fractions straight across, then sine over sine cancels, and that leaves us with cosine x is equal to 1, and you found exactly what you need. You're down to one trig function of cosine is equal to the value of 1. For number 10, the sine of x equals 3 times cosine x. So you can do a few different things. Since I'm allowed to algebra, I'm going to go ahead and try to isolate. I already have a number here, so I'm going to try to isolate that number by dividing both sides by the cosine of x. Now, when you divide the left side by the cosine of x, you'll see sine x divided by cosine x, and hopefully that triggers a bell. Because we know that sine over cosine is tangent. So we know that tangent of x is equal to 3. For number 11, cosine x equals cotangent x. Again, you can do a few different things. I'm going to choose to leave cosine x alone, and I'm going to choose to rewrite cotangent as cosine x over sine of x. And then what I'm going to do is, since I don't have a value here, I'm just going to try to get rid of these fractions, essentially. I'm going to put the left side over 1, and then I'm going to cross multiply. So then when I cross multiply, I get the cosine of x times the sine of x equals 1 times cosine of x. And then if you notice that both sides have a cosine, I can go ahead and divide both sides by cosine x. And then that leaves me on the left side with the sine of x equals cosine x divided by cosine x is 1. There may be other answers to these, 9, 10, and 11. These are 3 of the more obvious ones. Depending on how you changed your trig functions, it's a possibility that you found another one trig value or another one trig function equal to one trig value. Number 12 and 13 are proofs. Things to remember about proofs. You cannot cross over the equal sign. I recommend you starting with the more complicated side first. When in doubt, if you don't know what to do at all, convert everything to sines and cosines and see if that gets you somewhere. Number 12, prove that 1 over tangent of x equals cosine of x times cosecant. I'm going to choose to change a couple of things here. I know that 1 over tangent of x is cotangent. It's the reciprocal. So then cotangent is equal to, I'm going to leave cosine of x alone, and I'm going to convert cosecant into its reciprocal, which is 1 over sine. And then I can treat the right side as it's a fraction or a number times a fraction. So I'm going to leave the left side alone. Cotangent x is equal to, if I multiply these two fractions, I get cosine x over sine of x. And we know by definition that cosine over sine is cotangent. So then you literally get cotangent of x equals cotangent of x. And again, there are multiple different ways you could have done that. But the other thing to remember with proofs is you cannot assume that your reader knows anything. You have to show only, or you have to show one step at a time, unless it's something like this. Like in this first step, I changed a couple of different things, but nothing that couldn't be followed really easily. Especially if you just use a quotient identity, that's acceptable. If you do too many things in one step, or you assume, or you don't show something, period, that's where you're going to get some points off. Number 13, prove that cosecant, the x plus cotangent x over cosecant x equals cosine x plus 1. Lots of different options here. I think the left side's more complicated, so that's the one I'm going to try to simplify first. I noticed that I have a fraction with a monomial in the denominator, meaning that I could rewrite this fraction into two separate fractions that are both divided by cosecant. So if I do that, I get cosecant x over cosecant x plus, ooh, someone must be at the door, cotangent x over cosecant x. All right. Cosecant x over cosecant x is 1. Puppies! Plus, now I'm going to rewrite cotangent and cosecant because I don't really know how to simplify it as is. So cotangent I'm going to change to be, using my quotient identity, that's going to be cosine x over sine x. All over, I know cosecant, I can write its reciprocal as 1 over sine x. Now, reason for doing that is I knew that both of those had a relation to sine. So then what I can do is this will be 1 plus. I can rewrite this stacked fraction as a fraction multiplied by the reciprocal. So cosine x over sine x times the reciprocal will be sine x over 1. Oops, I should be keeping a trail of the right side the whole time. I apologize. Cosine x plus 1. Okay, and then on the left side, I get 1 plus cosine x over sine x times sine x over 1. Those signs cancel, leaving me just with cosine x over 1 is equal to cosine x plus 1. And we know because of the commutative property, but that both of those things are equal to each other.